Number 8 is asking you to use integration techniques to evaluate this given definite integral. So it's an integral from 1 to 2 with natural log of x plus 1 over x squared dx. So let's go ahead and think of the different techniques that we know. So we know like u substitution, integration by parts, partial fractions, trig substitution. So it looks like none of these really work. I can't do partial fractions when there's a natural log. A u sub doesn't appear to work. There's no trigonometric functions in there. So what I'm going to do is I'm going to go ahead, I'm just going to apply partial fractions to it. So remember with, not partial fractions, I'm going to apply integration by parts. So remember, if I go ahead and write out iPad, remember this is how I figure out what my u and what my dv are for integration by parts. So I stands for inverse trig and logarithm functions, P stands for polynomial, E is exponential, and T is trig. In this case, I do have a logarithmic function, so I have to choose this for my u over choosing x squared. So my u is going to be natural log of x plus 1. My dv is going to be equal to 1 over x squared dx. So what I can actually do is I can go ahead and write this in a tabular method. Even though I'm only going to do it once, it's probably good for notation. So this is my u, this is my dv. So I have natural log of x plus 1. And then I have 1 over x squared dx. So when I go ahead and derive this side, natural log of x plus 1 derives to 1 over x plus 1. This integrates to negative 1 over x. So now what I can do is I can do plus, and I can turn this into a minus. So when I go through and actually solve for this, my new integral is equal to negative natural log of 1 plus x over x. And I have minus minus, so that becomes a plus. The integral of 1 over x times x plus 1 dx. So uv minus the integral of v du. Okay, good. So this is not an integral anymore. So we could solve this right now, but I want to solve the entire integral before I plug anything in. It's just good notation. So now I need to figure out a way to solve this. Now it doesn't really look like integration by parts will work anymore. But what I can do now is, because I have two linear roots on the bottom, I can actually apply partial fraction decomposition to it and figure out what they will be. So in this case, I want to take this integral, and because it's two separate linear roots, remember I can write a constant on top for both of them. And I can figure out what they'll be when I separate them. And what I'm going to do is I'm just going to set this off to the side. This is going to kind of be its own equation of 1 over x, x plus 1. And this is how I'm going to solve for a and b. So remember, when I have two separate linear roots that are independent, to solve for a and b, I can use cover-up method. So for the first cover-up method, what I'm going to do is I'm going to cover up for x. So x is equal to 0. When I set this equal to 0, I need to cover up this and this in this term. So what I actually end up getting is I end up getting that a is equal to 1. So when I cover up all these terms, I end up just getting 1 over x plus 1 is equal to a. I plug in x equals 0. I end up getting a equals 1. Now I need to plug in x equals negative 1 to solve for b. So when I end up plugging this in, I cover up here. I cover up this term. I also cover up the bottom of here. So what this tells me is that b should be equal to negative 1 in this case. And make sure that you practice cover-up method for this final exam, because it's going to be a mixture of everything you learned over the entire semester. So now that I know what a and b are, I can go ahead and rewrite this term with this integral now separated. So this is going to be equal to negative natural log of 1 plus x over x plus 1 over x minus 1 over x plus 1. And I still need to integrate both of these terms. But I can go ahead and do that. These are pretty straightforward to integrate. So I end up getting negative natural log of 1 plus x over x plus natural log of x minus natural log of x plus 1. And I do want to write absolute value bars around this just to be safe, because there could potentially be a problem if I do plug in a negative term. So now I have my complete solution for my integral. Now I'm going to evaluate it from 1 to 2. So I'm going to do it over on the side over here. When I plug in 2, I end up with negative natural log of 2 over 2 plus, or actually, sorry, natural log of 3. So negative natural log of 3 over 2 plus natural log of 2 minus natural log of 3. Then I have a minus sign. That minus gets distributed to all these terms, so I'm just going to write them in parentheses. So I end up with negative natural log of 2 over 1 plus natural log of 1. Natural log of 1 is 0 minus natural log of 2. Okay? So now I can go ahead and simplify some stuff. So I notice that I do have a negative natural log of 3 over 2 minus a natural log of 3. I can actually combine those terms, and I end up just getting minus natural log of 3 over 2 times a 3 up front. So imagine if this was like 2 over 2, this is 1 over 2, so I end up getting negative 3 over 2 times natural log of 3. Then I also have plus natural log of 2. Then I have a plus natural log of 2 down here, plus natural log of 2. So this ends up becoming plus, this would be, let's see, that would be 3 natural log of 2. So I have now ended up with my final answer. And looking at my answers in this case, it looks like I end up getting letter A, which is correct. So the only thing that would matter is that for letter A, these two terms are just reversed. But that's totally okay.
The Teaching Center, UF's Learning Resource Center.